Thank you, Stefan. Good morning. I am here to give you an update on the A350 program. I know yesterday you visited the final assembly line, so you are already to a certain extent up to speed. Therefore, my question was, what can I present today that would fit with the Innovation Days, but at the same time show where we are on the program, because this is really your exact question. And indeed, I think one of the most frequent questions I have to address when I meet some of you or other people, it's always, what are you doing different? What are you doing different in the A350 program to avoid what we had on the previous program, either in Airbus or at the competition? And of course, it's somehow an embarrassing question, because even if you believe you always do your best and you do it right, you always take the lessons. You have to be very modest when you drive a program of that size, because you know what you know, but you don't know what you don't know. So this is how can I approach this question, and how can I update? So I think I've decided to try to be very pragmatic, having in mind that this program is like a book. Every day we are writing a page of the book, and we don't know the end of the book yet, although we would like to know it, of course. So today, what is our focus? We have on this program, we have a lot of innovation everywhere. Innovation in the product, innovation in the way we prepare the next phase, we anticipate the next phase, and today the next phase for us is a flight test. But also in the way we anticipate our own operations, how we will support the customers when comes the time of the entry into service, how are we going to prepare ourselves and our suppliers for industrial ramp-up, which is also a very important phase, and frankly speaking, this is the most important, because if we are able to ramp up and to deliver to our customer at the pace that we have foreseen, this is the key success factor for the program. So what is it that we are doing different, or at least trying to do different, to better anticipate the hurdles that we knew from the past program, or that we can anticipate due to the change in the product? That will be more the major driver for this presentation, if you agree, and if you don't, I'm afraid I have no choice anyway. But I'm sure the planning question is one of yours, and I would start straight away by addressing it. So this is the planning that was published and presented to some of you and to our customers, and this is the real planning that everybody is working to, suppliers internally, our customers as well. And this planning is meant to enter this A350-900 in service in the first half of 2014, and frankly it will be closer to the middle of 2014 than to the beginning. So this is where we go, and the key milestone that we have ahead of us is certainly the first flight. What we did in the last 6 months has been extremely significant for the program. We had two major milestones. One was to start the final assembly line, and you could see yesterday where we are, and I will elaborate a little bit more on this today. And also start the system installation for the first flying aircraft, MSN-1. Fast start was with the static test specimen. So this was the challenges, and I think we are on a good track on these two milestones. And then going forward, it will really be the final assembly line of MSN-1 and how we prepare the flight test program. This preparation is usually done with a lot of testing, meaning to bring maturity into the systems and to facilitate integration and the flight clearance later on, and of course in parallel our production lines will now steadily produce new components, and in order to feed our final assembly line and to go progressively from the rate we are today to rate 1 and then further on. So these are all the things that go in parallel, both industrial, technical, and a lot is going on at the moment, and almost every day. For instance, yesterday I was in Donauwörth and inaugurating and accepting the first set of those for MSN1, while today we were, and I will show you at the end, we were moving the ES from the station 50 in the FAL into the station 40. So a lot's going on, but I will not spend too much time on the product itself. I think it's been the subject for Innovation Days before, and just this very simple chart to remind ourselves that this is a very innovative family of product, not just the 900, but the whole family, and this is going from the clockwise. We would start with, of course, what everybody knows. It's a composite aircraft, major dominance of composite material in this aircraft, but also a lot of improvement on the system, even though we start from the F100M and for the FC80 basis. There is no huge difference in terms of architecture, but very significant improvement. For instance, here is mentioned our new cockpit design with large displays, and it's really a breakthrough. Of course, we have this new engine, the XWB engine, developed by Rolls-Royce, and which brings a very significant part of the economics that A350 delivers to our customers. And the rest is coming from obviously the material that we use and the high degree of optimization of the aerodynamics shapes of our aircraft, for which we have used in a very extensive way all the computation techniques that we have today with us. And last not least, of course, and this will be at the end what the customers will see, a lot of innovation in the cabin, in its design, in its comfort, in its efficiency, and also for the comfort of the passenger. The way we can, through the use of the carbon fiber cell, and without penalizing the performance of the aircraft, fly the cabin at a much lower altitude. So all this is embedded in our product, and it's very much changing the rules everywhere. And this is, of course, in particular true in the airframe itself, where we have moved not only Airbus, but also all our supply chain to this new world, which is not just dealing with structure, but also dealing with all the system integration into the structure. It's really a new world, industrial world, technical world, which affect the whole value chain for the product. What we can just remember here is that on the choice of CFRP inside this aircraft, of course we have gone to a very large extent in the full composite aircraft, on the wing or on the fuselage, but we've kept some metallic parts where we thought that the trade-off was really not working well for the composite, and this is, for instance, the case of the very front fuselage, where for many reasons, including system integration, but also including operations, we decided to stay with a metallic part. Otherwise, the other characteristic that was a big debate at the beginning of the program was our integration concept. Should we go with full barrels? Should we go with large panels, very long panels? And we decided, as you know, that we would go for large panels concept, which in fact we will see a little bit later that it's a little bit of a mix that we have. So I think we have made the right choice by having the right material at the right place. And today our industrial process tends to demonstrate that from an integration point of view, from an assembly line point of view, we have also made the right choice with our panel concept. So that's the framework, the technical framework in which I have to drive this development program. So the exam question was how to bring enough maturity throughout the development program and everywhere. And yesterday Tom Enders was calling that we have introduced and we follow very thoroughly the notion of technology readiness, both for the technical side and the manufacturing side. And this, one of the exam questions was to accelerate the readiness of the carbon fiber technology for being ready to get in full production with such an aircraft, while only 4 years ago, if I refer to 2006, it was in Airbus, it was the very beginning of this journey. So from the beginning, we had to develop our sizing tool, and here what we've made different, we have one sizing tool, Y sizing tool, which is used by everybody, all the design, all the straight guys throughout the program, not only in Airbus, but with our risk-sharing partners as well. So that when we have the validation or when we have further improvement of this tool, it benefits to all. This was a very big and important decision taken at the beginning, and then we had the progressive testing of demonstrator, starting from components to sub-assemblies. You remember probably some of you at least that we were 2 years ago showing this 2 barrels generation, these 2 fuselage barrels generation, which have tremendously contributed to the maturity of our product. And now we are very much at the end of the journey, and 2012, 2013 will be dedicated to large-scale and very large-scale demonstrator. I can only show 1 or 2 examples of this in this short presentation. And this was an important test that we had last year, which was meant to demonstrate that our crash resistance concept was working. The requirement is very simple. It has to be like a metallic aircraft. Sometimes we are constrained by the authorities although we have a new technology, we have to compare to what it was before on the previous technology. And here, this was the exam question, and we had developed a concept on our fuselage, the lower part of the fuselage, that could replicate or be better than a metallic aircraft of today. And this was the final demonstration, which worked very well and could demonstrate the accuracy of the modeling that we had developed prior to this test. As you can imagine, this test was thoroughly simulated and modeled before we went for the actual test, and then we can obviously refine the modeling even further and optimize even further the definition. So this is very much the kind of demonstrator, and we have many of them which aim to anticipate what we will be finding on the real testing where we are getting now. And I could mention in this area we had built a pylon which has gone through a series of fatigue testing already. We had also built a rear section with the vertical tail plane that we have also exposed to fatigue testing. So that's a lot, and this has a goal. These are the goal to de-risk as much as we can. But you're never sure. Right? You have to be always modest in front of these technology changes. It's for really de-risking the big testing that we are now preparing. The aircraft that you saw, the fuselage of yesterday, is going to, in the summer, to move to the testing hangar. We're going to use the L34, the Lagardère 34 building, the same as for the A380 in the past. We have transformed this building to be able to accept the A350, and we have now designed a completely new load introduction system that fits the A350. But what is new here is that in parallel, and just before it, we will have run the test on a fully modeled, on a full finite element model of the aircraft. The new computing tools that we have now enable to have bigger and bigger models, and this is the first time that we will have this kind of model. This will be in order to rehearse the test, in order also to then further optimize the test, and in case something would go wrong, to be faster in the repair strategy that you would have. This is very strong cooperation, collaboration between modeling and testing, and this is the right way to go in order to de-risk as much as we can the program, knowing that you are never 100% immune to a problem that could go wrong. So very much the same was applied on the systems. Here our key word for system is how can we be more mature when we get at the first flight? How can we be almost service ready when we come to the first flight? Not just go for the first flight with what you have, but go to the first flight with what you need for entry into service. And this has always been our strategy, and which is first of all based on different testing strategy, do more at the supplier, have a more functional approach. Go step by step to more and more integrated testing, and finally have a flight clearance for the first flight, which is really close to a flight clearance for a certification start. So this is the concept. What can I show today on top of what we were doing in the past program? First of all, I think this is something that we've never done before. A virtual platform that in front, before you have all the actual hardware and software, you can use this virtual platform with models of all the equipment that are then going to be delivered by our suppliers, integrated in the modeling, in the model's point of view, well before you can integrate the hardware. And this is really important, because thanks to this you can really debug a lot of things at the model level. And this is then a way to go much faster in the integration of the test means, the big test means that we are now running. And at the end, it's also like a third simulator. Today we have 2 full simulators for the A350, and this is acting very much as a third simulator, much less expensive, much more flexible, where we can do actual testing and actual demonstration of aircraft performance. And this is one of the big changes that we have made, integrate very accurate models of the function and of the equipment well before we have them in real in hardware and software. So that's very much an asset for the program. And another big asset where we can be very proud of is that as you maybe saw it in the air yesterday, an A380 since February is flying an A350 power plant. It's not just an engine, also the engine is obviously the core of the testing, but it's all that goes around the engine, like all the electrical generation, like the hydraulic pump generation, which by the way feeds one of the hydraulic circuits of the A380 during this flight. It's all about the nacelle and the thrust reverser, so a bleed system, a lot of systems that go along with the engine, including avionics that go along with the engine, and FADEC, etc., are flying now on the A380 and are being exposed well before the certification testing to a lot of conditions. Yesterday it was relight testing, for instance. How can we relight? What is the envelope of flight in which you Mach and altitude in which you can actually relight the engine. So this is testing that is a huge asset for the program when you can do it 1 year before the first flight, because then you have time eventually to adjust your algorithm and optimize the flight envelope. So that's a big asset, and beside these, we have all these more classical test means that we have with this Iron Bird in Toulouse, where when coupled with one of the 2 simulators we have also in Toulouse, which is really the pilot environment, and all the avionics software and hardware that goes with it, when coupled together, they give you the aircraft zero, which enable to actually first fly this aircraft in completely real environment. And beside this, we have a lot of other means for the air generation system with this Honeywell test bench in Mexico, in Mexicali, the city in Mexico. Here we have all the, from APU to air generation, air conditioning packs. We have all the chain integrated. Again, that's the first time we're doing this to this extent, and doing this much ahead of the first flight will enable us, together with the cabin zero, to really optimize the end-to-end process from air capture to generation and ventilation of the cabin in the cabin zero. Obviously, we have a landing gear test bench, and in Bremen we have our classical I-Live zero, where we can simulate test failure cases for all the flight controls and contributing to takeoff and landing. And this is a very short video showing you what a test means, like the landing gear zero means. This is in Filton. We have installed the main gears as well as in the back. If you are very cautious, you can see the nose landing gear as well in the back. It's in already, but it will come back, don't be afraid. And here it's a big asset, because it's not just the gears, it's all the avionics, all the software, including the doors and everything that contributes to this very big function, which is a A350 function, which is now being tested, and we have 1 year to optimize all the adjustments before we prepare the first flight. And you can see now the nose landing gear coming back. One of the performance driver for this aircraft is how fast we can retract the gears at takeoff, and this is obviously a very important contributor to the aircraft performance. So that's very much the technical side of the flight test preparation. But of course there is much more. And if I come to the industrial side for our operations and how we make our operations converge with the preparation of our airlines operations later on. This is a couple of topics that I'd like to address now. And here we come to our principle in this program, which is DMU, Digital Mockup, is really the master. Digital Mockup is a huge library of data that we share with all our risk-sharing partners, that we can access in real time through all the tools that we put in place at the beginning of the program. And this is really a breakthrough compared to what the A380 was. But I think I already presented this. But now it's what is it that makes a difference today in the phase we are in when building the aircraft, the first aircraft, managing the configuration of the development aircraft and the first customer aircraft. I will mention here two elements. One is, of course, discipline. Discipline, which is DMU quality gates. And we have implemented from MSN1 at the very beginning of the program a very strict quality gate process, which we've been developing through the A380 program, which has made a difference, frankly, in the A380 program when we started to improve the delivery performance. And we are reusing, but we are reusing it from day one and from MSN1 onward. So this discipline is there. And there is another functionality which is also something that is coming from the A380 in terms of almost dream at the time. Could we have all the electrical design implemented in the DMU? Not just the design itself, not just the routing of the harnesses, but the whole thing, including the enrichment that the manufacturing engineering need to have in order to produce their work orders for the shop floor. And putting all this in the DMU is a huge advantage, because then you have automatically consistency between the design and the work orders. And you can, by this, not only get to this full consistency from A to Z, but also we save a lot of time in the production of the installation drawing. When you are at the end of the process, you have the harnesses, you have the brackets, but you still need the installation drawing, because this is the way the shop floor can work, they need at the end of the drawing. But the drawing is almost an administrative process. Now it just all the information are in the DMU, not only design but also manufacturing. So these two elements, I think, are making a difference and will make a difference in the future when we start ramping up head-up version after head-up versions. And the other topic I'd like to mention is how this panel concept actually works. And I took the example of this of the rear fuselage. The rear fuselage is a very long fuselage. It's almost 20 meters long from the back to the front, where we joined with the center fuselage. And this is the architecture. In fact, the rear end up to the rear pressure bulkhead is a full barrel. That is, we call it a section 19. And then on top of this full barrel that gives the geometrical reference, then we build the panel. We build the panel in two steps, the lower and the lateral shells, and then finally the upper shells. And when you do that, we can ensure perfect tolerancing at the joint level, and we track these tolerances with laser tracker, and then we feed this data into the final assembly line. And this explains why we've been able to go so fast in the assembly line, in order to, when we came the time to integrate, and you will see the video just after, when it came the time to integrate two sections together. And this is seen from the inside, this panel concept. It's the rear fuselage down the cargo area, and this is showing how it all goes together. But I thought that showing quickly this video, which was taken in April when we started the assembly of the junctions, the assembly of the fuselage sections for the static test specimen. You can see here the section 1521, which is the center fuselage, a very complex, the most complex fuselage section, arriving in the final assembly line at the beginning of April, and then we started to move it to the station 50 and start the assembly. And I think it was an important phase because, okay, it's always theory until you have actually made it. And we did make it, and I think everybody in the final assembly line was very pleased with the way this all came together, the tolerancing and the best fit that we could demonstrate, and you will see that this couple gets on well. You see here, there is almost no room for the sealant, but there is still some sealant between the two. So this, I think, is for us a big satisfaction, and moving forward, a very important asset for our file and pre-file assembly process. And now, I'm just going a little bit further in the development program. When we talk of, we have 5 development aircraft, of which 2 are equipped with cabin, and this is, I think, the first time I'm displaying this, the configuration of our first cabin-equipped aircraft. So it's still a test aircraft, so there is the compromise to be done. There's still a lot of instrumentation, so of course we have some constraints, but we've tried to have a real layout, a very comfortable layout, with a lot of business class in there, 42 business class, 210 YC class. So it's a configuration with some constraints due to instrumentation, in fact. And I think what was important, we will use these 2 aircraft in the flight test program for very important tests. And finally, MSN5 will be used for route proving, because it will be extremely close to the first customer's aircraft in terms of structure and general condition. And we've tested, by building, we've tested internally our customization process well before